A quiet moment begins now. This is a slow and gentle space where calm science ideas move softly, one after another, without hurry. The purpose is simple. Small pieces of knowledge arrive quietly and then pass by, leaving room for rest. Light from a distant galaxy can travel for more than 10 billion years before reaching Earth. When that faint light touches a telescope, it carries information about a place that existed long before our planet formed. In this calm setting, each fact appears slowly, like a distant star becoming visible in a dark sky. Nothing here needs attention or effort. The mind can simply drift while soft pieces of the universe unfold. Galaxies are enormous gatherings of stars, gas, dust, and dark matter. Gravity holds these parts together in slow and patient motion. A typical galaxy may contain hundreds of billions of stars. Each star quietly travels around the galaxy's center, completing an orbit over millions or billions of years. Between those stars lies vast space. Even within galaxies, the distances are so large that stars rarely come close to one another. Our own galaxy is called the Milky Way. It contains a broad, flat disk of stars that stretches roughly 100,000 light-years from side to side. A light-year is the distance light travels in 1 year. Light moves extremely fast, about 300,000 kilometers each second. Even at that speed, crossing a galaxy takes a very long time. The Milky Way is not still. It slowly rotates. Stars near the outer regions take about 200 million years to complete one orbit around the galactic center. The center of the Milky Way contains a massive object known as Sagittarius A star. This region is calm from our distance, quietly shaping the motion of nearby stars through gravity. Many galaxies also contain similar massive centers. Some galaxies appear as graceful spirals. Their arms curve outward like soft cosmic streams, filled with clusters of stars and gentle clouds of gas. Others are smooth and round, known as elliptical galaxies. Their stars move in many directions, creating a calm and uniform glow. There are also irregular galaxies, which have no clear shape. Gravity, time, and past collisions have slowly reshaped them. Galaxies are not evenly scattered through space. They tend to gather in groups. Our galaxy belongs to a small gathering called the local group. It includes several dozen galaxies moving slowly through space together. One of the largest neighbors is the Andromeda Galaxy. It sits about 2.5 million light-years away from Earth. Even though that distance sounds enormous, Andromeda is slowly moving toward the Milky Way. The motion is very slow on a human scale. The two galaxies may gently merge in about 4 billion years. When galaxies merge, their stars rarely collide. The spaces between stars are simply too wide. Instead, gravity slowly reshapes both galaxies, mixing their stars into a new, larger structure. Throughout the universe, billions of galaxies exist. Each galaxy quietly holds its own system of stars, planets, gas clouds, and dust. Astronomers observe distant galaxies using large telescopes that gather faint light. One important telescope in orbit around Earth is the Hubble Space Telescope. It has helped reveal galaxies that formed billions of years ago. Another powerful observatory is the James Webb Space Telescope. It can detect infrared light from extremely distant galaxies whose light has stretched during its long journey. As the universe expands, light traveling across space becomes slightly longer in wavelength. This quiet stretching is known as redshift. Redshift allows astronomers to estimate how far away a galaxy is. Some galaxies appear as they were when the universe was very young. Their faint light has been traveling toward us since before Earth existed. Galaxies also contain gentle clouds of gas. Within these clouds, gravity slowly gathers material until new stars begin to form. A newborn star gradually ignites nuclear fusion in its core. Fusion releases energy that shines outward as light. Over time, stars quietly evolve. Some grow brighter, while others slowly cool. When stars eventually reach the end of their lives, they may release gas back into the galaxy. That gas becomes part of future stars. In this way, galaxies slowly recycle their material across immense spans of time. Dust within galaxies also plays a quiet role. Tiny particles of carbon and silicates drift through space, absorbing and scattering light. These dust clouds can appear as dark lanes across glowing star fields. Sometimes they gather into calm regions where new stars will later form. Many galaxies contain star clusters, which are groups of stars born from the same cloud. Some clusters remain together for billions of years. Others gradually disperse as gravity slowly changes their paths. The universe itself is extremely quiet on large scales. Sound cannot travel through the vacuum of space. Instead, galaxies move in silent patterns guided by gravity. Even large galactic collisions unfold slowly over hundreds of millions of years. From Earth, these distant events appear as still images in the sky. Light from far galaxies arrives gently, carrying soft traces of ancient cosmic history. The night sky above Earth holds only a small fraction of what exists beyond our view. Powerful telescopes reveal that nearly every small patch of sky contains distant galaxies. Some appear as faint spirals. Others glow as soft ellipses of light. Each one represents billions of stars moving quietly through space. Galaxies themselves also gather into larger structures called clusters. These clusters may contain hundreds or even thousands of galaxies. Gravity links them into slow cosmic systems. Several clusters together can form enormous superclusters. These are among the largest structures known in the universe. Even these giant structures are separated by vast, empty regions. Astronomers sometimes describe the universe as having a web-like structure. Long filaments of galaxies stretch across space, while wide voids lie between them. This cosmic web formed gradually as gravity drew matter together. Dark matter also plays a quiet role in this structure. Although invisible, it contributes much of the gravitational pull shaping galaxies. Without dark matter, galaxies might not have formed in the same way. Scientists study distant galaxies to understand how the universe changed over time. Each observation is like receiving a message sent long ago. The farther a galaxy is, the older the light we see. In this gentle way, astronomy allows us to look back through cosmic history. Across billions of years, galaxies slowly grow, merge, and evolve. Stars form, shine softly, and fade. Gas clouds drift and gather again. All of these processes unfold in patient silence across an immense universe. And as the light from those distant places continues its quiet journey through space, it slowly reaches the instruments on Earth, bringing with it another calm piece of the vast and quiet universe. Across the universe, the quiet motion of galaxies continues without interruption. Each galaxy drifts through space as gravity gently guides its path over immense spans of time. The space between galaxies is even larger than the space between stars. These distances are measured in millions of light years. A light year, again, is the distance light travels in 1 year. Even light, moving at its constant speed, takes millions of years to cross the gaps between galaxies. Because of these vast distances, the universe appears calm and slow. Galaxies move, but their motion is gradual. On human timescales, the sky seems still. Within many galaxies, stars form inside large clouds of hydrogen gas. These clouds are cold and quiet regions of space. Gravity slowly pulls the gas together. Over time, the gas becomes denser. When enough material gathers, a new star begins to shine. These star-forming regions can glow softly with pink or blue light as young stars illuminate the surrounding gas. The life of a star may last billions of years. Small stars burn their fuel slowly and steadily. Larger stars live shorter lives but shine more brightly during their existence. When stars eventually release their outer layers, they return gas and dust back to the galaxy. This material drifts through space until gravity gathers it again. In this way, galaxies slowly recycle their contents. Some galaxies appear bright with many young stars. Others are quieter, filled mostly with older stars that glow gently with reddish light. Elliptical galaxies often contain older stars. Their appearance is smooth and soft, with little visible structure. Spiral galaxies, on the other hand, display graceful arms that curve around a bright center. These spiral arms contain many regions of active star formation. As galaxies rotate, stars move in long circular paths around their centers. One complete orbit can take hundreds of millions of years. Our own Sun is part of this slow journey. The Sun takes roughly 225 million years to complete one orbit around the center of the Milky Way. This long movement is sometimes called a galactic year. Since the Sun formed about 4.6 billion years ago, it has completed only about 20 galactic orbits. The center of many galaxies contains a supermassive black hole. These objects hold enormous mass within a very small region. Despite their name, black holes do not act like cosmic vacuums. From a distance, their gravity behaves like that of any massive object. Stars simply orbit around them. Only objects that move extremely close may be drawn inward. Some black holes release energetic jets of particles that travel far beyond the galaxy's center. These jets can extend for thousands of light years. Even these powerful events unfold slowly when viewed from Earth. Light from distant galaxies is often faint. Astronomers collect that light using very large mirrors. Some ground-based telescopes are built on high mountains where the air is clear and stable. Locations in deserts or remote regions are often chosen for these observatories. The Atacama Desert is one such place. Its dry air and high elevation allow astronomers to observe distant galaxies with great clarity. Large telescope arrays can combine observations from multiple instruments. Together, they create extremely detailed images of deep space. One famous deep space observation revealed thousands of galaxies in a tiny region of sky. Each small point of light represented an entire galaxy. Some of these galaxies are billions of light years away. Their light began traveling toward Earth long before our solar system existed. Astronomers also observe galaxies in different wavelengths of light. Visible light reveals stars. Infrared light can pass through dust clouds and reveal hidden star-forming regions. Radio waves can show large clouds of hydrogen gas. X-rays can reveal energetic regions near black holes. By combining these different observations, scientists build a clearer picture of galactic structure. Galaxies themselves can vary greatly in size. Some dwarf galaxies contain only a few million stars. Others contain trillions of stars. Dwarf galaxies often orbit larger galaxies. Over time, gravity can pull them closer. Sometimes they slowly merge into their larger neighbors. This process adds stars and gas to the larger galaxy. The Milky Way has absorbed several smaller galaxies in its long history. Streams of stars moving through the galaxy are evidence of these ancient mergers. These streams are the remains of galaxies that once existed separately. Over billions of years, gravity gradually blended them into the Milky Way. Galactic collisions are common across the universe. Yet even during these events, individual stars rarely collide. The space between stars remains vast. Instead, the shapes of the galaxies slowly distort. Spiral arms stretch and curve. New waves of star formation may begin as gas clouds compress. Eventually, the two galaxies settle into a new combined structure. Astronomers observe many examples of galaxies in the process of merging. Some appear connected by long streams of stars. Others show bright centers where gas is gathered. These processes unfold slowly over hundreds of millions of years. In the quiet darkness of space, time moves gently on cosmic scales. Beyond galaxies lie enormous regions called cosmic voids. These areas contain very few galaxies. They stretch across hundreds of millions of light years. Between these voids are long filaments where galaxies cluster together. This structure forms the large-scale pattern of the universe. Gravity slowly shaped this pattern over billions of years. The early universe was more uniform. Small differences in density gradually grew under the influence of gravity. Matter slowly gathered into the first galaxies. Those early galaxies were smaller and less organized. Over time, they merged and evolved into the larger galaxies seen today. The expansion of the universe continues even now. Galaxies that are very far away appear to be moving away from us. The farther a galaxy is, the faster it seems to recede. This steady expansion stretches the fabric of space itself. Light traveling through expanding space gradually shifts toward longer wavelengths. This shift produces the red colors astronomers observe in distant galaxies. Redshift provides a way to estimate cosmic distances. By measuring redshift, scientists can learn how long the light has traveled. This allows them to study different stages of cosmic history. Looking deeper into space is also looking further back in time. Some of the most distant galaxies observed today formed when the universe was only a small fraction of its current age. Their light has traveled for more than 13 billion years. These ancient galaxies appear small and faint. Yet they represent the early stages of cosmic structure. The universe contains far more galaxies than once imagined. Modern observations suggest that hundreds of billions of galaxies may exist within the observable universe. Each one quietly holds countless stars. Planets may orbit many of those stars. Gas clouds drift slowly through their galactic environments. All of this motion unfolds with great patience. Across immense distances, galaxies continue their silent movement. Their light travels calmly through space, carrying quiet traces of the vast and gentle universe. In the stillness of space, galaxies continue their gradual evolution, shaped by gravity and time. Each movement is subtle, unfolding across spans so large that change appears almost unnoticeable. Within galaxies, interstellar gas exists in different forms. Some regions are cold and dense, while others are warm and thin. These differences create a quiet balance that influences how stars form. Cold molecular clouds are among the calmest places in a galaxy. In these regions, atoms bond into molecules, most commonly hydrogen molecules. These clouds can stretch across many light years, drifting slowly through the galaxy. Over long periods, gravity causes parts of these clouds to contract. As they become denser, the pressure and temperature inside begin to rise. Eventually, a new star forms at the center of this gathering material. The formation of a star is a slow and steady process. It can take millions of years from the initial collapse of gas to the moment the star begins to shine. Once a star forms, it settles into a long period of stability. During this time, it gently converts hydrogen into helium in its core, releasing energy that travels outward as light. Different stars shine with different colors. Some appear blue, indicating higher surface temperatures. Others glow with a soft red tone, showing cooler temperatures. These colors create the varied appearance of galaxies when viewed from afar. Clusters of stars can form within the same region of a galaxy. These star clusters may remain bound together by gravity, moving as a group through space. Open clusters are loose collections of stars that gradually disperse over time. Globular clusters are more tightly bound, containing thousands or even millions of stars packed into a relatively small space. These clusters often orbit the outer regions of galaxies, moving in smooth and stable paths. The light from a globular cluster appears as a soft, concentrated glow. Within galaxies, dust plays an important role in shaping what can be seen. Dust grains are extremely small, yet they can block or scatter light. This creates dark regions within otherwise bright galaxies. At the same time, dust helps cool gas clouds, allowing them to collapse more easily and form new stars. In this quiet way, dust supports the cycle of star formation. Some galaxies contain large amounts of gas and dust, leading to ongoing star formation. Others have used much of their available gas, resulting in fewer new stars. These galaxies appear more uniform and calm, with older stars dominating their light. Over billions of years, galaxies can change their appearance. A spiral galaxy may gradually lose its defined arms after multiple interactions or mergers. An elliptical galaxy may form from the merging of several smaller galaxies. These transformations happen slowly, guided by gravity and the distribution of matter. Galaxies also rotate at different speeds depending on their structure. In spiral galaxies, stars closer to the center orbit faster than those farther away. However, observations show that outer stars often move faster than expected. This behavior provides evidence for the presence of dark matter. Dark matter does not emit or absorb light, but its gravitational influence affects how galaxies move. It forms a large invisible halo around galaxies, extending far beyond their visible edges. This halo helps hold galaxies together. Without it, stars at the outer edges might drift away over time. The exact nature of dark matter remains unknown, yet its effects are observed across the universe. Beyond individual galaxies, interactions between galaxies can lead to the formation of tidal features. These are long streams of stars and gas pulled out by gravitational forces. Tidal tails can stretch across hundreds of thousands of light years. They move slowly, tracing the past interactions between galaxies. Some of these streams eventually fall back into the galaxy. Others continue drifting through space. These features provide quiet evidence of events that occurred long ago. In galaxy clusters, the space between galaxies is not completely empty. It contains a thin gas known as the intracluster medium. This gas is extremely hot, yet very diffuse. It emits X-rays that can be detected by specialized telescopes. The presence of this gas adds to the total mass of the cluster. Galaxy clusters are among the largest gravitationally bound structures in the universe. They can contain thousands of galaxies, all moving slowly within the cluster's gravitational field. The motion of galaxies within a cluster is complex but remains steady over long periods. Some galaxies pass close to one another, influencing each other's shapes. Others remain at greater distances, moving in wider orbits around the cluster center. Clusters themselves can also merge. When two clusters come together, their galaxies pass through each other while the gas between them interacts more directly. These mergers can release large amounts of energy, yet they still unfold over hundreds of millions of years. The large-scale structure of the universe continues to evolve as gravity draws matter into denser regions. Filaments of galaxies grow more defined, while voids expand. This gradual process shapes the cosmic web. Observations of distant galaxies help scientists understand how this structure formed. By studying galaxies at different distances, astronomers see different stages of development. Closer galaxies appear more mature. Distant galaxies show earlier stages of formation. This layered view provides insight into the long history of the universe. Light from distant galaxies often passes through intergalactic space before reaching Earth. Along the way, it may interact with gas clouds, leaving subtle absorption patterns. These patterns reveal the composition of matter between galaxies. Even in the emptiest regions, traces of hydrogen and other elements exist. These faint signals help map the distribution of matter across vast distances. The universe is filled with a quiet background of radiation. One example is the cosmic microwave background, which is a remnant of the early universe. It fills all of space with a nearly uniform glow. This radiation provides information about the universe when it was very young. Galaxies formed long after this early period. Yet they carry the imprint of those initial conditions. Over time, gravity transformed small variations into the large structures seen today. Stars, galaxies, and clusters all emerged from these early differences. Throughout all of this, the universe remains calm on the largest scales. Motion continues, but it is gentle and steady. Light travels silently through space, crossing immense distances without interruption. Each galaxy contributes its own faint glow to the overall brightness of the universe. From Earth, only a small portion of this light is visible. Yet instruments continue to extend our view, revealing more distant and older galaxies. These observations deepen our understanding of the quiet processes shaping the cosmos. And across the vast expanse, galaxies continue their slow movement, their stars shining softly, their structures evolving with patience, as time extends onward without end.